By double integration, find the area lying between the circle r equal to a sine theta and cardioid r equal to a into 1 minus cos theta. This is very important. First of all, before starting the solution, let's learn how to plot the graph for r equal to a sine theta and the cardioid r is equal to a into 1 minus cos theta. So to plot the graph for r equal to a sine theta, the values, we have to calculate the values of r. The values of theta are given over here. Suppose if theta is 0, then putting 0 over here, you get r to be as 0. And for theta equal to 30 degree, what is sine 30? It is 1 by 2. So r will be a by 2, which means 0.5 or a, or you can also write a by 2 or 0.5 of a. And then putting theta equal to 90 degrees, so this is 1. So r is equal to a into 1, that is a. So now I'm going to plot these points over here. Now at 0 degree, the r is 0. This point. And at 30 degree, the radius is a by 2. If suppose this is point A, this distance is a from the origin, then at 30 degree, this is your 30 degree angle. And at 30 degree, I'm having the value of r as a by 2, that is the radius as a by 2, that is the midpoint, this. Just so here, I'm tracing this to this. So here, this is the point. And at 90 degree, r is a. Suppose I also need to plot for 60 degrees, suppose. So because I need one more point. So let me also plot for 60 degree. For 60 degree, what is sine of 60? It is root 3 by 2. Yes. And a times root 3 by 2, that will give you approximately 0.8 of a, approximately. So writing the point at this angle is your 60 degree. This is 30 degree and this is 60 degree. So at 60 degree, I'm having the value 0.8, nearly here. So I'm taking this point, rotating this point to this point. So this is the required point for theta to be at 60 degree and the radius is 0.8 of a. And then when theta is 90 degree, you get the value as a. So for 90 degree, this is your a. Just move this a to 90 degree. Please remember, this is a and this is also a. Please remember, this r is the radius from the origin, right? So this is the point. Okay. So which means the circle is like, I'm plotting the circle as these are the points. Let me plot. Write this. Okay, fine. This is the graph for half of the circle, and for the symmetry about theta equal to pi by 2. Now if theta changes to pi minus theta and the equation remain unchanged, then we are having the symmetry about theta equal to pi by 2. So let me put here, instead of theta, as pi minus theta. So I get r is equal to a sine of pi minus theta. And because I get, when I subtract theta from pi, I will remain in this second quadrant. So if I subtract theta from pi, this pi minus theta is sine of pi minus theta is sine theta, because in the second quadrant, all the values of sine are positive for the second quadrant. So the equation remain unchanged. So there is also symmetry about theta equal to pi by 2. Like this. Not so clear, but approximately just a rough sketch. Okay, so this is the circle that is r equal to a sine theta. This is how you can plot the circle. Okay, now to plot the graph for r equal to a into 1 minus cos theta. This is your cardioid, and let me write first the values for r and then we just plot. When I put theta equal to 0 over here, I get cos of 0 as 1 and r is 0. For theta equal to 60 degree, the cos of 60 degree is 1 by 2, that is 1 minus half is half. So I get a by 2. And then if I put theta to be as 90 degrees, so cos of 90 is 0, so I get a. And if I put theta equal to pi, that is 180 degrees, so cos of 180 is negative 1. So this will be twice of a. So if this is a, then this is 2a. And this is negative a and this is negative 2a. Again, I must say that when you plot, you please remember that this 2a and negative a, this is just a distance from the origin for the radius, right? Okay, so let's plot. What is the value for r for 0? When theta is 0, r is 0, which means this point. And then for 60 degree, this angle is 60 degree. I have already plotted. So this is your 60 degree angle. At 60 degree, I'm having the value a over 2. That is the mid value, this. So just move this point to here. So this is the point. And at 90 degree, I get a. So just move this point a to here. This is also a. The radius from the origin, the distance is a. Okay, so then for 180 degree, I'm having twice of a, which means this is negative a and this is negative 2a. But the distance from the origin is at here twice of a. So the point will be here. So the graph of cardioid, the graph of cardioid is like this. All right. Is it okay? Or should I make this again because already the point is missing? Okay. Okay, fine. This is the graph for the cardioid r equal to a into 1 minus cos of theta. Right. So this is how we just plot the graphs for the circle and cardioid in polar coordinates. These are the polar coordinates. So let's move on to the exercise. Find the area lying inside the circle r equal to a sine theta and outside the cardioid r equal to a into 1 minus cos theta. So I have to plot the circle and the cardioid together here. So for circle, I already know that this is the radius. Let's say this is a and this is negative a, this is negative 2a, and this is 2a. Now for the circle, to plot a circle, I'm having the point 0, 0 first. And I'm going to plot the circle with green color pen. So the first point is this. And then I'm having the point for 30 degree, I'm having the point half of a. That is this point at 30 degree. Let me draw the 30 degree angle first. This is suppose the 30 degree angle. And this is your 60 degree angle. Okay, So for 30 degree, I'm having the point as a by 2. So moving this point, this is 0, this point up to this. This is the required point. And then I'm having, for 60 degree, I'm having 0.8. So approximately around here, 0.8 of A. And this angle is 60 degree angle. So I'm moving this point as imaginary. This, you don't need to draw this. This is only just for the clarification that how I'm getting this point. And then at 90 degree, I get the value A. So this is 90 degree. So here I get the value A, which means this is the point, the required point. So let me draw the circle, and symmetry I already get because it is symmetrical about theta equal to pi by 2. So I'm drawing the circle. Hope so it will draw well. Okay, I'm drawing the circle. This one, and by symmetry. All right. Not bad. Okay, now let's draw the cardioid. I'm drawing this with this color. First point is 0, 0. We all know that. And at 30 degree, sorry, not 30 degree, but I'm taking the 60 degree. At 60 degree, I'm having the value A by 2. So this is the 60 degree angle. So here I'm having the value A by 2 for the cardioid, this point. And then at 90 degree, I get A, the value A. And at 180 degree, I'm getting the value as 2A, right? Not negative 2A, but a distance from the origin, that is 2A unit. Okay, that because it is a radius. So let me draw this cardioid now. Okay, so this is like perfect. All right, just wait. Okay, it's fine now. Now I have to find the area lying inside the circle and outside the cardioid. This is your cardioid, and outside the cardioid is this area. And this area is also lying inside the circle, the green colored one. So this area we have to find out. What is the lower limit for R? Because what is the point at, what is the R at this curve? This is the curve for the cardioid, and the value of R is here, A into 1 minus cos of theta. And the value of R on the curve, on the circle, that is R is equal to A sine of theta. So let me take this to be as a lower limit and this to be as a upper limit from here to here. Okay. So theta will vary from, yes, theta will vary from, because the region lies in the first quadrant only. So theta will be varying from 0 to pi by 2. Right. If you want to get the values of theta from the equations, from these two equations, you can also get the values of theta by equating these two as A sine of theta is equal to A into 1 minus cos of theta. And then this A and A will go on. So this is sine of theta is equal to 1 minus cos of theta. Taking this cos theta to the other side, this is sine of theta plus cos of theta equal to 1. Squaring both the sides, you get sine square theta plus cos square theta, that is 1, plus twice sine of theta cos of theta, that is equal to 1. And then this is sine of 2 theta, which is, that will go, this is equal to 0. So 2 theta is equal to either 0 or it is 2 pi. Sorry, or it is pi. So the value of theta is 0 or pi by 2. Right? Whatever way you can get the values of theta. And then the required area. Now the lower limit for r is taken to be as from the cardioid a into 1 minus cos theta. And the upper limit is to be taken as a of sine theta, and the limits for theta is from 0 to pi by 2. Now solving the inner integral from 0 to pi by 2, this is r dr. So this will be r square over 2, and the limits are a 1 minus cos of theta and a sine of theta d theta. Putting the limits, let me take 1 by 2 outside, and now putting the limits, putting a sine theta in r, so this will be a square sine square theta minus, putting a into 1 minus cos theta here, I get a square 1 minus cos of theta square. Simplifying this, I get, okay, let me take this a square also outside, right? So this is sine square theta minus, opening this, a square plus this is b square minus 2 cos of theta. Very fine. Now I'm changing this sine theta into the cos theta, that is 1 minus cos square theta. So this is equal to a square over 2 from 0 to pi by 2. So this is 1 minus cos square theta, and then minus 1 minus cos square theta, and then this will become positive 2 cos theta, and then d theta. So this is a square over 2 from 0 to pi by 2. This will vanish, and this is, writing this first, okay, minus 2 cos square theta plus 2 cos of theta d theta. Let me take now 2 also outside, then that 2 will cancel out with this denominator 2. So a square remains here from 0 to pi by 2. Okay, solving this integral first, d theta, and then 0 to pi by 2, solving the other one, cos square theta d theta. So the integration for cos theta is sine theta, and putting the values, okay, in the next step. How to calculate this integral? I'm going to use the reduction formula here. So this is a square, alright. The power is 2 here. Just subtract the power with the odd numbers for the numerator. So 2 minus 1. And then first write the power and subtract the power with the even numbers. But even numbers is 2. So 2 minus 2 will give you 0. So you have to leave that. So, and because this is your even power, so you also have to multiply with pi by 2. But if the power is odd, there is no need to multiply with pi by 2. Pi by 2 is multiplied only for the even powers. So this is a square. Sine of pi by 2 is 1. Minus this is 0. So this 1. Minus a square. This becomes 1. So this is pi by 4. Taking a square common, so this will be 1 minus pi by 4. This is the required answer. Thank you so much. Do like and subscribe for the latest videos. Stay blessed.